All right. Hello, my name is Audrey Grabesic. I am the owner of Modular SureSite, which is a company that provides modular consulting services for residential and commercial projects. I also own the media company called Offsite Dirt, which is presenting this amazing event with Arup today. We're going to be discussing modular construction roles and responsibilities from several of their integrated team members for fire, structural, facets, and acoustics. So thank you very much, all of you, for being here. We appreciate it. And if you have any questions, we would love for those questions to be in our chat so that we may answer all those questions at the end of this experience with meeting each one of these team members. As you know, we have 4 questions that we're going to be bringing up to our team members, and we're very excited about it. Again, this is my offsite construction company called Modular SureSite. We work nationally right now, doing several projects in Colorado, in Illinois, Texas, and several other states. So we're kind of expanding quickly in this amazing industry that we call offsite. And most of the information and details that I work on is with modular construction. So welcome, and thank you for being here. So Arup, we shape a better world. This integrated group is amazing because of not only the experience they have, but how they are the pioneers in the industry for sustainability, for structural, for fire applications. I've been completely impressed with everything that I've seen, and I had the opportunity to speak with one of their team members, Kelly, that was able to help us integrate and put this together. Thank you, Kelly, for doing this for us. Really appreciate it. As you can see, we're just keep adding more people. I love it. They have amazing amounts of consulting and engineering services that they provide. Everything from acoustic to digital to environmental, fire, life, and safety design. And they were founded in 1946. They are among more than 14,000 people in 88 offices across 33 countries. And then Arup in the Americas, as you can see, are pretty much in the, I would say, the big city locations and expanding, it seems.
Yeah, so I think I could take over from here, Audrey, if you'd like.
I would love that. Thank you, RJ.
Okay. Yeah, so this is just a bit about our modular and off-site capabilities at Arup. We've done a lot of work across the U.S. and Canada, and we've worked alongside manufacturers to do their research and development for their modular systems that they're developing or have already, or they're partially developed, or they're just trying to finalize, and also helping them explore this new market. And we've also spent a lot of time advising government and corporate modular programs, and we've also done a lot of research and consulting as it relates to codes and standards development. Next slide. I'm just going to go through 2 quick of our projects that we've done recently. So we have a on-call service with Full Stack Modular, who's a modular manufacturer. We initially worked with them on the Atlantic Yards project, also known as the Dean Street project in Brooklyn, which at the time was the tallest modular building that was completed. And so for this, we're just continuing our work with them and continuing to advise them on their modular applications that can be found around New York City, and also expanding out to LA. So this one in particular was a 10-story affordable housing building located in the Rockaways. It utilized 6 column modules with an integrated moment lateral system. Next slide. This is another project we're working on, and it's the AHF Madison. It's for the AIDS Healthcare Foundation, and it's a 236 unit, 15-story affordable housing project as well. and it's being designed to Type 1A construction requirements. So that's non-combustible construction with unlimited height and area. And so the superstructure relies on the eccentrically braced steel frames for lateral seismic force resisting system. That probably means a lot more to the structural engineers than it does to a fire engineer, but it's really interesting stuff. They could probably tell you more about it than I can. So yeah, we could jump into the next slide. This was a report that we put together for the for CSA. It was basically what it was a landscape study on the state of high-rise modular construction across North America, and we spent a lot of time analyzing the current state of the industry and the drivers for growth to address the challenges that exist with modular, and there's a lot of them. So we're just trying to get a better grasp on those so we can work through them. And so the study, which was published last year, included interviews and a workshop in Toronto with some industry stakeholders to inform on opportunities for future standards development within modular construction. If you want to learn more about this, there's the link at the bottom here or you could just Google CSA Arup high-rise modular research or something of that nature. It should come up, and it's really interesting, and it really does do a good job with a comprehensive look at the challenges that the industry is facing and some paths forward. This is another example of another project we did. We've done a few of these Citizen M hotels located in DC, New York, and Seattle. We provided multidisciplinary services from SMEP to acoustics, lighting, fire, lead, security. And the interesting thing about this is it's in a high seismic area, which is another unique challenge on top of just the modular. How are we going to get that to work with seismic considerations in mind? And so this was based on a concrete core lateral system surrounded by steel modules. Now I'm just going to do a quick introduction of each of the panelists that are here, and I guess we'll start with me. My name's Richard Joseph Petrie, but I go by RJ. I'm a licensed professional engineer, and I have a lot of experience in fire and life safety consulting, fire alarm design, computational fluid dynamics, and I also have been getting into the structural fire modeling world recently. And when it comes to modular, I've done some work in the New York City area when it comes to the nitty gritty with Chapter 7 of the New York City Building Code, which governs the structural portion of these modular projects, and just figuring out how to make modular work within that framework.
Hi, everybody. This is Tali Mijakovsky. I'm an associate principal in the Facade group in New York with Arup. I'm also a licensed professional engineer. And I come from a structural background before facades. So I like it when RJ talks about lateral wind force systems as well. I also really like getting into the nitty gritty of the facade detailing. Excuse me, my experience with modular has been just that, working with one of the modular manufacturers on some of the R&D work that they're doing for their system and trying to see how they could improve the detailing and make it work so that it's functioning properly for air and water infiltration and allowing mostly for adjustability on site and construction tolerances. So that's my interest in modular.
Hello, I'm Jordan Woodson. I'm a senior structural engineer with Arup. I'm also a licensed professional engineer, and I'm in our DC office where I've been for 9.5 years at this point. I've worked on a few modular projects, mostly the Citizen M projects that RJ was mentioning, both the one in Seattle and in Washington, DC, collaborating with a modular supplier called Polcom, based out of Poland. I've also worked on a number of other building typologies across my career, including airports and residential buildings. So modular focus recently, but some also other typologies as well.
Good afternoon, everyone. My name is Joe Solway. I help lead the acoustic team in Arup's New York office. I've been working with Arup for 24 years and have been involved in a number of modular projects. I led the acoustic design for the 32-story Dean Street building as part of the Pacific Park development, and have been working on other modular projects over the last decade. So good to be with you all today.
Thank you so much for that overview. We appreciate you all being here, and with your specific disciplines, I think it's going to be a really interesting conversation. So we're going to start off with our panel discussion, and our first question. Can you provide an overview of each construction role for fire, structural, facades, and acoustics for modular construction? So who would like to take that one? I have Jordan, if you'd like to jump in, that would be amazing.
Yeah, I'm happy to kick that off. I think, generally, I think the starting point is what type of modular construction are we looking at? Is it something that is looking to integrate all of these offerings into one module that stacks on site with limited on-site work? Or is it modular in the idea of a sort of kit of parts structural system or structures only? Or is it, modular bathrooms? I think understanding what type of modular system we're trying to deploy is pretty essential. And then on the design side and on the consulting side for Arup, sometimes we are under a modular supplier who has a set system, and that's something that we're trying to help them deploy effectively for specific projects. And then sometimes we're working with architects trying to help them figure out how to go modular on a project where they might not be considering it from the development side. And then I think once you understand what those systems are, you're setting sort of a structural system off of that, but then figuring out how you integrate these other disciplines, site-specific fire needs for local authorities, how you integrate structural tolerances with facades, and then depending on what that structural buildup is, how we achieve the appropriate acoustic rating for the system at hand. But I'll pass it to my colleagues for their individual considerations.
Yeah, I'm happy to go next on this one. So in terms of fire engineering, outside of our traditional, code consulting for the means of egress and the fire life safety systems that are going to be present within the building, there's a lot more detail that we get into with regards to Chapter 7 of the building code. And this chapter usually is going to tell you it does tell you what the types of structural elements are and how to protect them in a fire. And also with regard to the fire separation requirements within the building for fire barriers and things like that. So the code was developed with conventional construction in mind. Modular was not on their mind when they started to develop the IBC. And so there becomes a lot of times where you're trying to fit a square peg in a round hole. It's probably my favorite analogy when it comes to fitting modular into the traditional building code. So really requires a lot of careful consideration on how you're classifying all of your structural elements. And so we will typically help define a primary versus secondary member, and then whether each of those members need to be encased with fire protection all around them, or can they be just within a wall assembly and for a membrane protection. And so a lot of the issues that we see when it comes to modular is when it comes to the mate lines. When you in a traditional building, you have a lot of construction that crosses what we have where the mate lines would be if it was a modular building. For example, fire barriers are required to go from the floor to the underside of the slab above. But in a modular sense, if you continue through that to the underside of the slab above, you're then crossing into the mate line, which you have very little access to when it comes to assembling a modular building in the field. And so it's difficult to get in there to finish that fire barrier. And so often we have to come up with creative solutions on how to address that concern in the code, since we can't really build a fire barrier in the traditional sense. And so we do a lot of things. We approach a lot of those issues and think of creative ways to handle those. In addition to that, we've been a lot of resolving details for columns, walls, floor ceilings, and all the penetrations and joints that exist within modular construction. So we'll assist the architect or the manufacturer with their details in that. We help with product selection, like board products like gypsum, magox, and that sort of thing, versus intumescent and spray applied fire protection, and where that division needs to be between those, because when it comes to intumescent and spray applied, there's a lot of dry times and there's exposure to the elements during transportation that can make those kind of iffy if you want to use those. But also they're a lot easier to install than a board product in some cases. So there's a balance there. Fire testing, after we help develop the test details, and then we can witness the testing and help analyze the results. When it comes to the first step with this kind of stuff, it's all about just compiling the code requirements and really understanding what the client's objectives and goals are, and how the code addresses those, and how we need to think about those when it comes to the manufacturing process and the design of the overall system.
RJ, when you are doing your design, exactly what you're saying in this fire protection, do you also have to do a lot of the manufacturers that you work with install sprinklers in their factories and then finish on site? And then do you have to work with those fire departments, or what happens in that process?
So our MEP team has been doing a lot of this work. I know that typically what happens is you'll have a pre-installed sprinkler system as part of the mod. And then you'll have your, as part of another mod, you'll have like a corridor that has the main runs of all your sprinkler piping and stuff. And so in the field, you'll bring those mods together, and then you'll make the connection between the sprinkler pipes there. And we have worked with AHJs before to kind of go through this process with them, because I know that there is some concern when it comes to the way that these the sprinkler systems are being installed. So it's a project by project issue that we have to deal with.
Thank you.
So if I could just jump in on the facade side of what RJ was speaking about, we also have to look at how the facade is fixed to the mod, thinking about the fire criteria that he was mentioning. Usually the fire protection goes all the way out from the slab to the wall. So when we have moving from a traditional construction to a modular construction, the slab is now split in two across your mate line, and the wall is the element that now used to be able to be adjusted 360 degrees on site, and now we're trying to transition that to being installed in a factory condition and doing as little as possible on site. So what we're finding for the facade side of things is, how do you take an element that's typically used to being adjusted up and down, in and out, side to side, and where do those tolerances move to? So they end up moving to the structural mod, but the facade still needs to be able to be adjusted a bit once the mods are installed, to be able to account for any installation tolerances and things that change in the field. So we've been spending a lot of time drilling down into the details about how the facade panels are supported off of the mods, where they're supported off the mods, how that affects the fire protection, and the vertical and horizontal fire separation. Usually that gets, in a traditional structure, that gets filled in after the fact with fire insulation and smoke sealing in between floor levels. So how does that change when we split them and have a mate line? Also, in this temporary condition that we're not used to having with the modular construction, the top of every single mod is exposed to the weather. So how do we close it off in terms of water infiltration, such that we can build it sequentially and still maintain the envelope? So those are some of the challenges when we're looking at facades, depending on what type of modular system we're working with. We've been on projects where the jointing around the perimeter of each facade hasn't allowed for adequate tolerances and adjustability, and it leads then to a breach in either air or water infiltration. So that's super important. The same thing also, we're talking about acoustic separation too. If there's any holes, both from the inside, going from floor to floor, from fire, there's generally going to be an acoustic hole too. And then later we can talk a little bit more about materials and so on. But I think RJ already mentioned it. We generally try and use non-combustible materials, both on the inside and the outside. because we can't really sprinkler on the outside of the building. So we'll follow the code for the particular building type and function. Particularly when we get into residential, we're trying to avoid using materials where people inside are sleeping, and we could potentially end up with a situation where a combustible material can cause some damage.
I'll add to just on the acoustic that it's really helpful when, as an acoustic consultant, we can get on board early on a project, the projects where we're on at the beginning, and can think about the massing of the building and the adjacencies is very, very valuable to help minimize extra material costs for sound isolation down the road. So if you're thinking about, where are your sensitive spaces, where are your, say, your guest room, your bedrooms, the spaces people are sleeping, and where are your noise producing spaces like your elevator shafts or your mechanical rooms or your gymnasia, and thinking about the buffer spaces that you can create between them can really help in avoiding any potential acoustic issues down the road. And add to that, I think one of the the key things with modular is where you have spaces that cross the mate line. Say if you have a corridor and a part of a guest room or an apartment that's part of the same module, then the transmission of sound and vibration energy in that same module is much greater than if you have a mate line connection separating those two spaces.
Thank you. I think we definitely got that one covered. Appreciate it. One quick question for you. When we're talking about non-combustible materials and with building material increases, are you seeing any impact on any of those materials? Are you finding that you're integrating other ones from different areas? Just really quickly, I'd love to know a little bit more about that, Tali, if you can speak to that.
Integrating materials from other areas. So I'm not sure.
Other countries, are you finding that you're trying and testing different things other than maybe things that are built in the United States? Are you seeing an expansion in what you're trying to do, or what kind of facets are being used on your projects?
Yeah, so there's several. So in keeping with non-combustible materials, there's several other types that are used elsewhere around the world. Generally in the US, we stick with mineral wool because it's available and not as expensive. There's also glass wool and glass foam products, which are much more expensive and not easy to obtain and procure in the US. So there's a few options, but they're not yet, they haven't yet made it into a reasonable construction budget for the US yet. We generally stick with mineral wool.
Okay.
Also helps acoustically.
Yeah.
It's great thermally and acoustically.
Quick example from a fire site as well is we started to look at other board products in addition to just the typical gypsum. We've looked at some magnesium oxide board, which is we've seen an uptick in the production of recently. So we've been exploring using it. We haven't necessarily applied it to any projects that I can think of at the moment, but it's definitely an option. It's just a matter of making sure that supply chain will be fixed and be plentiful going forward in the future.
Yeah, the materials that allow reduced or no wet trades on site is certainly helping speed the production process up.
Thank you.
Yeah, generally non-organic materials. So like I would imagine for exterior sheathing, we might look at a cement board, for example, rather than gypsum as well. Though it's a bit heavier.
Thank you. Scott, are we going on to the next question?
Absolutely. Well, thank you for the answers to just set the stage for what all of your roles are. So hello, everyone. My name is Scott. If you're with us on the last panel, I was moderating the last panel in April, and I'll be co-moderating this question section with Audrey. So moving along to the next question, moving into the materials discussion, we're going to talk about cross laminated timber. And so our team, did a lot of research on Arup and the different ways where they're pushing boundaries. And one of the things that we found really interesting was the experiments that they're carrying out a series of independent large-scale cross-laminated timber construction experiments at a professional fire test facility called Arup in France. And so obviously the need to construct with timber is engaged in the construction industry globally, and Arup has a huge commitment to safety and sustainability. And we saw how they've been undertaking a series of full-scale fire experiments in a 380 square meter combustible apartment with input from Imperial College in London, and that experiment has successfully taken place. So their team is currently expanding the knowledge of the fire behavior of timber structures, which is currently based on tests on a much smaller compartment size of up to only 100 square meters. So the new experimental program that they have, it builds on previous research and explores construction arrangements to enable the safe use of construction laminated timber in large scale buildings with a particular focus on office, education, and residential sectors. So this will help develop further understanding of the fundamental fire safety considerations needed to inform safe design approaches. So we were starting to get into that material discussion, RJ. So if you wanted to kick us off on this one and talk about how your fire engineering department is exploring the safe use of cross laminated timber and what you guys are seeing there.
Sure. So just to set the stage with regard to large timber, the good thing about that from a fire point of view is that as the outer layer of the large piece of wood burns, it forms the char layer, which is essentially insulating the inside core of the timber itself, which will help insulate it from fire. Because after it chars, it's not going to burn any further than that. So there is that's the mechanism by which a lot of the heavy timber construction is passing tests. But so with regard to CLT specifically, we're very open to using timber at Arup, partially because it is very sustainable when done when properly resourced. So the good thing about CLT is that in the 2021 IBC, it's going to be allowed for use up to 18 stories, which is an improvement. There's a lot of construction that's going on currently in a lot of major cities that is utilizing timber construction. Not super tall construction right now, since it is still where most places are not under, they're still under the older codes that don't really address timber to the extent that the 2021 IBC will. But as we see more of this construction happening on these lower rise applications, more suppliers are coming online to meet the demand for this CLT product. So the good thing is that it's all has to be tested to the same standard as traditional materials, and we are seeing assemblies that are passing these tests. So from a regulatory point of view, there's an opportunity there to use it for depending on the fire ratings required in the building. So that's the good part about CLT, but there are some drawbacks when it comes to modular, because modular is already difficult, but including combustible construction can add a layer of difficulty. Not saying that it's not possible, but currently with our current codes, combustible construction eliminates a lot of past the compliance that we could use with the AHJs. The cost of concealed combustible space protection, like added sprinklers within the concealed space and the fire blocking that would be required is somewhat prohibitive at the moment. So anything beyond type 5 construction can get pretty difficult from a cost and testing point of view, as well as practicality. So it's cost prohibitive in that the amount of testing that we would need, or the amount of sprinklers that we would need to add to make it meet the code, can be limiting when it comes to taller buildings. That's why you're only seeing it in low-rise applications. So there have been some CLT modular projects that have been completed, but those are exclusively in Europe, and the US market is always going to be more difficult because of the regulatory requirements of the IBC and the AHJs that we have in the United States.
Tali, do you want to add to that from the perspective of facades and how CLT, what kind of impact that would have with you?
Yeah, so just generally CLT, the way we've seen it being used thus far in 2 of our projects is more in a structural capacity. So it's a slab condition. And depending on the type of facade, whether it's a window wall or it's a strong back system, which is some like a horizontal element, which is fixed at the top and the bottom of the structure or slab and the beam below it. The detailing between the facade and the structure, the CLT slab, will change because the CLT doesn't allow for typical facade detailing, which is sort of like an edge of slab bracket, which is usually inserted into the, if it's safe for typical structure, which is concrete on metal deck, you might have a halfin or a cast-in type anchor with an exposed bolt and then a facade anchor on top of that that you would then lock off. That doesn't work with CLT. So the detailing for the way the facade is fixed to the CLT is going to change entirely. It will require an angle back with lag screws, and those screws will have to go further into away from the edge of slab because they need to, you need to have enough of them, and they need to be able to create enough of a force to be able to resist the push-pull that they're seeing from the facade loads. So another plug for low-rise buildings, areas with lower wind loads, smaller forces that need to be pulled out from the CLT. And the other funny, we're using CLT for a structure for a building in Milwaukee at the moment. And the other funny condition has to do with thermal. So depending on how the edge of slab is detailed, the way I was just discussing it in the first example was that it's like a curtain wall where the facade is running past the edge of slab. The slab is inside. It's completely safe from all of the elements. Sometimes we get into buildings where the edges of slab get pushed closer to the exterior envelope line, and we just need to, need to worry about them thermally. Like when we have exposed slab conditions, like in Chicago a lot, Audrey will know this. There's lots of buildings where architects try to push the edge of slab and use a window wall arrangement, but those aren't great with CLT because you need to worry about moisture, not just water from the rain, but a vapor from condensation getting to the CLT because it's a organic material that potentially doesn't want to get wet, doesn't want to be exposed to any condition where it might start degrading. So on that project, we spent a lot of analysis time and detailing effort to show how the air-water vapor barrier needs to run around the CLT and exactly how much insulation and where it needs to be for the pretty strenuous conditions, the exterior conditions in Milwaukee are, that gets kind of cold in the winter, just to double check that we won't have an issue where the dew point line ends up being behind the AVB because we don't want the CLT to be susceptible to any moisture. I've not yet used CLT in any modular construction yet. There is a trend for using CLT aside from the structural capacity. You could think about using it in the vertical capacity as part of a facade panel. But then it sort of lends itself to some of the questions that RJ was speaking about. We still have to deal with fire protection. To what extent, what does it need to be a fire rated wall depending on the adjacencies? Can we use it in a vertical application? Architecturally, it's great because the interior finish of the CLT panel could be your interior wall. You do have some funny conditions around the perimeter and the jointing to consider. Usually that stuff is hidden. And then for the outside face of the CLT, it would still need to be waterproofed and insulated and clad, say like in a rain screen arrangement with any material. Again, it could be wood, but then that does point to some of the questions we were speaking about earlier about combustibility. So there's lots of potential. CLT would be great also because of the slab, the CLT on the facade panel inherently has some lateral stiffness to it. So that's another benefit, but we need to get around what the regulatory rules are, whether or not they can pass NFPA 285 for the edge of slab conditions, especially at the mate lines of the mods. So there's some challenges still to be used in modular construction. And we're still at the point of ironing out challenges with CLT in traditional construction at the moment.
Joe, would you like to give us the acoustics perspective?
Sure. So, CLT, like a lightweight modular, has some acoustic issues related to sound isolation, especially vertically. So, there are ways to get around that or to mitigate that. Often with CLT, we're using a combination of CLT with concrete to give us enough mass in getting better vertical sound isolation. We are doing some CLT that's purely lightweight though, but then you're looking at some fairly complex buildups of CLT with isolated hung ceilings and isolated resilient floor buildups to give you both good airborne and impact sound isolation. So it's possible to do it lightweight, but it requires a more complex buildup from the floor to ceiling assembly.
And then Jordan, if you want to bring us home with a structural perspective there.
Yeah, I mean, I think to take a step back to cross laminated timber, or mass timber in general, which includes other sort of structural slabs that are similar to cross laminated timber, like dowel laminated timber or nail laminated timber, and then more conventional glue lam construction. There's been a big push to incorporate mass timber in structural designs and find opportunities to deploy it sort of across a number of markets. And there's a lot of interest in the industry around, one, its aesthetic, but two, its sustainability and its appeal from that perspective. Concrete, there's a lot of embodied carbon in concrete in general. And so finding ways to deploy mass timber and incorporate timber into our projects has been super appealing. Similar to the other panelists here, the applications to modular have been less frequent, but there still is the appeal. I think if you consider mass timber and you consider modular, there's a lot of overlap in terms of one, the need for a multi-disc team that understands sort of the many constraints that go into sort of this new structural or building technology. Having a fire engineer, structural engineer, MEP team, acoustics, and facade team that all understand those various constraints and how the levers that you're pushing and pulling affect the other team members is sort of vital to successfully getting a project off the ground. But a lot of the approaches that you would apply with CLT and specifically of how do you efficiently lay out panels so that there's replication on site. It's a lot of the same design approaches that you would apply in modular. But I think unless you're going taller, low-rise applications of CLT are frequently sort of circumvented by like light stick or conventional timber framing, because it's still allowed per local jurisdictions. It has a sustainability argument that it's still timber construction. It's lighter, it's conventional, and it can be still built pretty quickly and cheaply. So that's what it's up against, sort of on the low rise side. And on the high rise side, it comes with the complications that the rest of my teammates have flagged.
Well, thank you for those answers. So then we're going to move into, you briefly mentioned it there, Jordan, and we'll get into the structural engineering part of this to begin this question with, but on net zero carbon. So also in our research about you guys, about Arup, we saw that you proudly joined the Structural Engineer 2050 Commitment Program, supporting the need for coordinated action across the engineering profession to achieve net zero carbon by 2050. So Arup is a member of the inaugural group of signatories, along with 13 other leading firms for that commitment program. So as everyone on this call knows, structural engineers have a really important role to play in reducing greenhouse gas emissions from the building sector. But sustainable design has traditionally been the realm of the architect and other design team members. So structural materials, though, make up at least 50% of the upfront carbon embodied in the building, and they are a significant contributor to the building sector's impact on global climate change. So the move towards a zero carbon built environment must address embodied carbon. Our most widely used structural materials, cement and steel, are responsible for nearly 12% of worldwide greenhouse gas emissions. So it is crucial to slash their emissions if we are to stay within our planet's critical 500 gigaton additional carbon dioxide limit to avoid irreversible climate change. And that is a quote from Francis Yang, who is Arup's Structural Engineer 2050 Vice Chair. So obviously, this is really exciting to all of us on this call to see an organization of your guys' size leading the charge on this. So to begin with this question, I'll bring it back to you, Jordan. If you could talk about how you and the structural engineers at Arup are going to adopt these net zero embodied carbons with your sustainable principles.
Yeah, thanks. I think it's really important to sort of acknowledge we're really lucky to have sort of people like Francis within our team sort of pushing us to be more sustainable from a structural perspective. The industry, I think, is quite used to focusing on operational energy in buildings, sort of how buildings, specifically from mechanical and electrical perspective, consume energy off the grid and need that energy to operate their buildings throughout their life cycle. And finding ways to reduce that has been a key focus of the industry for the better part of 2 decades. But as we get better and better at that, that daily use of energy becomes less and less significant for the overall building's impact on the environment, and sort of the embodied materials that comprise the building, mainly structural, can be focused on as a way to reduce embodied carbon and sort of the impact of buildings on the built environment. So that's where the focus has gone, and sort of this first step in this commitment, this SE 2050 commitment, is really about one, it's advocacy, and two, it's an educational process of making sure that the industry understands that we have the ability to design better and create more sustainable structures through a commitment to understanding sort of how embodied carbon plays a role in the built environment. So, right now, I think the main focus is a data collection perspective, really trying to understand what the actual embodied carbon is of the materials we're using. We don't have as much information that we have on sort of the energy side. So what we've started to do is just ask for that data from suppliers. What is the concrete mix that you're supplying, and what is its embodied carbon? And then once we sort of are able to set benchmarks a bit more clearly, we can start to ask for improvements on those benchmarks in either a sort of prescriptive manner, or just ask a supplier to find better ways to source materials such that they don't have as much embodied carbon associated with them. So that's been a key role on sort of the structural side. Certain materials are much better than others. There's a lot of energy that goes into making cement. And so there's quite a bit of embodied carbon in the process of using reinforced concrete. Mass timber is quite a bit better if sustainably sourced. So there's easy ways by selecting different materials, but there's trade-offs in terms of fire performance, span to depth ratios of the structural members, and other impacts just sort of across the board. So it's really about education and sort of trying to bring that conversation into the planning process of buildings from a embodied carbon perspective. From the modular perspective, it's the same thing. It's how do we efficiently use materials, and modular is a great way to do that because you're pulling more and more of the construction process offsite, and allowing us to efficiently apply construction approaches that produce less waste and ultimately provide a more efficient structure.
Tali, what are your thoughts on this?
Yeah, Jordan did a really good overview. It's the same with every discipline that's using materials. So for structures, it's steel and concrete and looking at how we can reduce the embodied carbon of those materials, or even the use of those. But for facades, it's glass and aluminum. Those are the materials that have the highest embodied carbon content, which falls nicely because if we try and reduce the fenestration openings and increase or reduce the window wall ratios, increase the opaque areas for any building, not just modular, then that does then help lead towards the reduction in the operational carbon that we spoke about as well. So it's a win-win. So we're trying to tackle this question from many sides, look at the materials for embodied carbon, try and make the facade glazing to opaque ratio reasonable and reduce the glazing as much as possible. Where we have glazing, try and use high performance materials to improve the thermal performance of the overall envelope. Where we have opaque materials, maximize the thermal performance, use copious amounts of mineral wool. The detailing should be such that we reduce the air and water infiltration. So we're not adding any more work for the mechanical system to be able to have to compensate for the performance of the facade. And then within the facade components themselves, there's a push towards a couple of different, buzzwords out there: lean design, designing for disassembly, circular economy. So trying with the materials that we do need to use, trying to make sure that we can reuse them, not over design. So design the sections as efficiently as possible so that we don't use more material than we need to. And then if something fails in the future, or for some reason it has a reduced design life compared to another component, design it in such a way that we can disassemble that piece and replace it. And again, that can be used both for modular and for traditional. It's just more about the way we think about how we use materials in facades, but also in buildings generally.
RJ, would you like to go next?
Yeah, sure. So as Jordan kind of touched on a little bit, is when it comes to fire, the product selection, it's going to draft.
RJ, we lost your audio, I think.
Hello?
We can hear you now.
Oh, okay. Sorry. I was just saying that the product selection is important to from a fire perspective because it impacts the fire performance. We know a lot about prescriptively how concrete functions and how gypsum functions from a fire perspective. We know there's prescriptive requirements that say X number of thickness means you're going to get X number of hours of fire resistance. But as we shift away from those and use less of them or use new materials, then we're gonna have to start doing some fire testing to better understand those materials and how they perform in a fire, and so we can have those same benchmarks that we have for concrete and gypsum. And especially when it comes to modular, a lot of times we find ourselves looking for existing listed assemblies on UL's website, for example, and comparing them to the kind of buildups that we have that are being proposed for a modular system. And so we can kind of gauge the performance that way. But as we get further away from those traditional kinds of systems and traditional materials, we'll have less existing UL listings to benchmark our assemblies off of. And so that'll also require some more fire testing to get a better understanding. But I think it's just part of the process of introducing new materials into the market, is that we just need to get a better understanding so we know how to use them and where to use them.
And Joe?
Yeah, I mean, one thing I would add would be that, we've seen with modular construction that it does lend itself to prototyping and having being able to do small scale mock-up testing of horizontal or vertically adjacent modules. So the ability to mock up the two adjacent modules and test for different materialities helps to fine tune what you actually need from a fire or acoustic or thermal perspective. So we've seen the ability to actually, try different floor ceiling assemblies and then scale it down to what we need to meet the project goals through iterative prototype testing, which ultimately then, once you apply that to a whole building, can significantly help reduce the amount of material you're having to put into it.
Thank you. Moving on to our last and final questions for the team. You guys have been doing amazing, and thank you so much for your insight. The demand for modular construction is increasing in response to urbanization, housing affordability, construction labor shortages, rising labor costs, and persistently stagnant construction productivity. Modular construction also reduces construction waste, as we've kind of spoken about, alleviates disruption to the community, and can provide a safer environment for construction teams. Modular construction contributes to a number of United Nations Sustainable Development Goals and aligns with Arup's commitment to sustainable development progress and to the shaping a better world. In the last decade, there have been several high-rise modular buildings constructed by your team. In recent projects, the engineered by Arup include a 32-story tower at 461 Dean Street in Brooklyn, and 19-story Citizen M Bowery in Manhattan, New York. Arup provided a range of multidisciplinary services from structural MEPs and fire engineering to acoustics. High-rise modular constructed represents a significant opportunity to advance the construction sector in North America, as shared by Dwayne Torrey, which is your P&G Director of Construction and Infrastructure for the CSA team. Our question to you, with the significant opportunities with high-rise modular construction, how many new projects do you have in the US in 2021 and 22? And are you seeing more opportunities high-rise hospitality, multifamily, and or residential? And are you also developing more sustainable solar or net zero design? So Joe, we're going to have you start first.
Sure, thanks, Audrey. Yeah, absolutely. We are seeing a number of projects continue and start in both in residential, in commercial hotels, both single family residential, but then also multi-story residential. And it's something we're not just seeing in the US, but we're seeing in our offices in Europe, in Australasia, in the UK too. So it's something that's sort of feeding on itself as we're learning globally, not just regionally, but globally from each other about these projects. And I think as we see more construction firms having specific teams that are dedicated to modular, that we're seeing the efficiencies of having people that have gone through the process and understand the pitfalls and how to avoid them getting ironed out. We're seeing some of the issues that we saw in some of the earlier modulars of the rate of installation exceeding the rate of construction of the individual modules getting ironed out. So I think a lot of the issues that we've seen in the past are certainly causing people to want to do more modular than they had in the past. I think you're muted, Audrey.
Yes, I am. RJ, well, how are you feeling about that on the fire side? Are you seeing that you're starting to integrate more into the modular space?
Yeah, we are. We're seeing, I mean, we, as I mentioned before, we have projects spread across the US and current and past projects in New York City, LA, DC, Seattle, a lot of major cities there. And so what we're seeing is, I think as AHJs get more comfortable with this idea, it is new to them, and it's kind of foreign. So the more comfortable they get with the more projects they see, and the better that we convey the design intent and how the design works and how it meets the code, the less anxiety they're going to have about approving these kinds of projects. And as the AHJs get more comfortable, I think you'll see more people willing to move into the modular space for all the benefits that have already been mentioned. The construction, the speed of construction, the less material waste and things of that nature. So I think it's definitely trending in the right direction. And then as more projects come online, the more comfortable people are going to be with it.
Yeah, I agree with you. Tali, do you have anything to add to that?
No, I'm agreeing with my colleagues. We're seeing it happening more and more. Our particular discipline is looking to get involved more and more as well. And there's definitely an economy of scale for taller, repetitive building types. So we are seeing more of those sorts of projects than the small one-offs. I don't expect that we would be involved in any single family residential projects, but hey, you never know.
Totally possible. You just never know. Agreed. Well, thank you.
I mean, more in a traditional module, but those would be heading towards, printed building construction, different type of modular mindset that we might talk about at the next panel.
I would love that. That would be awesome. Jordan, we're going to have you close it down. Are you seeing, in your capacity being in structural, we were kind of discussing that before everybody joined us. I'm seeing more structural engineers being able to adapt this process a little bit quicker than most of the other engineering areas. Would you agree with that?
I would. I think, I think generally, where we're finding ourselves more and more is tied into specific manufacturers and their own sort of approach, and a lot of this comes down to how you connect each module to one another and sort of how to do that quickly, efficiently, and with tight tolerances. And so as more and more research and investment goes into that, that becomes more and more proprietary. And so I think that's where we're getting seeing ourselves present on projects more frequently, is in that role, working for a supplier, really trying to hone a technique and an approach so that they can go deploy their system on a number of different projects successfully. So that's where we're seeing ourselves. It's less sort of in the conventional role we sit in on a project sort of structure, like as a sub to an architect, and more helping deploy a structural system. And once you just understand that system, you understand its limits and how to effectively detail it.
Yeah, I agree with you. And I think it's really interesting. You were talking about the manufacturing side. We have this whole engineering side, but then we also have to work with the factory and kind of understand how they use their building systems and their processes, and then adapting to those and having that form of communication. And I think I'm finding out mostly in this space is really the pre-construction and developing the right team and having that proper communication, because a lot of this is, once you've kind of gone through that first process, it seems to get easier and easier, right? Maybe with that same group or that same company, but it's really establishing the right team members in the beginning. Would you guys all agree with that?
Yeah, I would. I think to the point I made earlier about having a multidisciplinary team that understands sort of all the impacts, as you pull levers on the other disciplines, it's important, because it's very easy to go to a structural engineer and find a great structural solution that then screws everybody else over. Understanding how you impact the other trades is vital, and the manufacturing side is and install side of that is a key driver in the project.
I agree.
And I would agree that they're more so modular than anything else. That the definition of how you achieve your fire rating between spaces directly impacts your acoustic separation. Tally already mentioned the same with the facade, right? It depends on how you define both the thermal and the acoustic properties of the facade, and then also the flanking that you're getting in between spaces. And then structurally, depending on whether you're using concrete or the mass of the structure, then directly impacts acoustics. So they're all massively interconnected. Yeah.
I agree with you. We're going to get to a couple of quick questions because we have a couple of minutes left with you. Darren actually wrote in the Q&A, we have issues abutting modular builds to existing traditional builds. Can you give some examples of how you've addressed this on previous projects, or have you? I'm going to start with Jordan because you're in the structural side.
Yeah, I'm curious if there's more clarity on the question in terms of what the issues are that are being faced. Is it about crane swings or movement?
Darren, are you on the panel? Are you here right now? Do you want to ask? Open up your mic. Okay, maybe Darren's not here. I'm guessing that he's talking about an existing, like bringing a modular build into the traditional build. Is there a way to use an existing structure and then add on modular onto it? Have you done anything in that space where you're bringing both disciplines together, the traditional and the modular together?
Yeah, I mean, I think on the Citizen M projects, what you'll frequently see is we have a sort of conventional podium structure that functions as your base layer, where you want a bigger column grid that modular can't necessarily deliver for retail and for sort of additional spaces. And so you have a sort of conventional construction platform, and then you stack modular on top of it on top of that main transfer structure. So you see that. You can also see it in the existing building world, where We looked at a project where it was 15 stories of concrete. If they wanted to reuse the foundations, they could cut it down to the foundations and stack 20 stories of modular, given that it's much lighter. So we've seen a number of applications like that for sure.
Great. Did anybody else have any other questions? I think we got it, and we did it all in 1 hour. It is amazing. Thank you very much, all of you. Thank you, Joe and Tally and RJ and Jordan. A special thanks to Scott. I really appreciate everyone being here. I think your insight, I think the forward thinking of your company and how you guys are all collaborating together in this crazy time of of COVID and what we're encountering in to working in different areas of the world and being able to connect is obviously such a great tool and a great asset. And we are so grateful for all of you for being here.
Great. Thanks, Audrey. Great to be here.
Thank you.
Thank you.
Thanks
Yes,
so
thank you all
much.
very much.
Thanks,
Hope
Scott.
you guys have a great day. I hope that you can join us next month, which will be the last Tuesday of the month for our next event here on Offsite Dirt. We're looking forward to expanding our offsite construction series. If you need more information, you can go to offsitedirt.com. If you have any great leaders in the industry, or if you want to be a contributing writer to our content management online, please get in touch with us, because we think that sharing the conversation, having this dialogue, and being able to educate people in an area that's ever expanding is one of our main goals, not to mention being able to have the right people in the industry, and having those discussions is also a great way that we lead our industry forward. So thank you, Scott. Thank you, RJ, Tally, Joe, and Jordan for all your time today. We wish you a great rest of your week, and thank you.
Thank you.
Thank you, everyone.
Thank you.
Thank you.
Thanks.